Hi all, this is Dr. C. Labesh Kumar from Institute of Aeronautical Engineering, Dundigal. So today we are going to discuss about coolants and machinability. So earlier we have already discussed different things related to machining process. So today we are discussing related to coolants and machinability. So what are the coolants used in machining process as well as what is machinability is what we need to have understand. So the course outcomes, if I say, so the similar course outcome for the earlier what we have discussed, the same cutting tools as well as coolants and tool materials behavior during the machining process is what we are going to learn. So cutting fluids, it is already termed as coolants. So coolants are those fluids which are used in cutting operation to make the machining process very simple. That means when machining is carried on, there will be three different types of heat zones are created. Generally, the name of those zones are primary heat zone, secondary heat zone, and tertiary heat zone. So if you want to remove the heat, we need to apply some cutting fluids. So the cutting fluids are applied for giving an assistant in the cutting operations. So generally, it may be used for cooling the work environmental or tool environmental, or to reduce the friction, or to improve the surface finish, or to have not a corrosion on the parts produced, or it may be used for chip breaking or taking the chip away. But the general purpose of cutting fluids or the coolants is to cool the environmental of the cooling. Thereby, the heavy heat can be carried away with respect to the coolant. So generally, the cutting fluids are applied in between tool and workpiece so that the operation of cutting will take place very smoothly. So why you will apply cooling or coolant means, so generally to make the tool into the normal temperature, that is the first thing. The second one is that to have proper temperature at the workpiece zone. So generally the heat is created because of the work and the tool environment interaction. So this is the zone where the maximum heat is liberated. So this zone is the primary zone. So the primary zone is very effective in the machining process. So to make them into the room environmental, we are going to use the cutting fluids, or to lubricate and reduce the friction between the tool and workpiece. So in general, there will be high friction created between the tool and workpiece. Thereby, what happens, the temperature increases more and more. To make them into a control part, we are going to apply cutting fluids. Next, if you want to have a proper surface finish, that is point number 4, to improve the surface finish, you are going to have a proper lubricating process. That means coolant application process. Next, we need to use it for avoid corrosion on the workpiece. So corrosion will occur in the material which can expose to the nature and form corrosive nature on the surface after machining. So this is the machined surface. If it is exposed to environmental, what happens? A thin layer of other material or oxidization will form. So to avoid this, we are going to have corrosion is produced on the workpiece, which is already been machined. So the work environmental created due to the machining process will create a small thin layer of oxidization on the finished product. So to avoid that corrosion, we need to use the coolant. Next, we do have chip are of 3 types. We already been discussed related to this: continuous, discontinuous, as well as build-up edges. So the continuous chips are very harmful. If you want to have a breakage in the continuous chips, we can also use coolant as a external agent to remove or to break it into a proper segments. Lastly, if you want to wash away the chips, so we can use these coolants. So in general, the purpose of coolant agent, why we are using this cooling agent in a sense, to cool the workpiece or to cool the tool, to reduce the friction, to improve the surface finish, also to reduce the corrosion on the finished product, to break the continuous chips, or to wash away the chips in a flow. So what should be the properties of the coolant? So coolant properties are very, very important, so that it should not be reactive when the machining process is taking place. The first property what we have here is high heat absorption. So the coolant should be selected in such a way that it should possess high heat absorption capability. If it does not possess high heat capturing capability, so it will lose its nature. That means it will not be useful in the machining process. Next, it should have good lubricating qualities. When the parts are running or the machining is carried on, so it should act as a good lubricating. That means it should reduce friction between the mating parts. So that is what a good lubricating quality stands for. So next, it should have high flash point. High flash point, in a sense, it should not catch fire when it is undergoing frictional nature. So that is what called as high flash point. The next one is stability. Stability means it should have its own nature. If it doesn't have its own nature when the process is taking place, if it changes its phases, then it loses its stability. So it should be stability due to the process. Next one is it should be neutral. Neutral, in a sense, it should not be reactive when the machining process takes place. If it is reactive, then the process of machining will have different results. That means there might be losing the proper nature of the workpiece. Next, it should be odorless. Odor is nothing but it should not possess any kind of smelly nature. Next, it should be harmless because the operator always stands near the machine and he uses it in multiple ways. So it should not harm the operator or it should not harm the process environment. Next, it should not be non-corrosive. So it should not affect corrosive nature. Then it should be transparency. Color adding will disturb the machining process. There should not be any disturbance in terms of machining process. If you use a color type of coolant, what happens, in a sense, the process of machining, you can't be visualized. So it will be a blind spot. So if you use transparency kind of a fluid, so we can observe the cutting process very clearly. The last but one is low viscosity. So it should be low viscous nature so that it has a proper flowing property. And then it should be of the low priced. So all these are the properties of the fluid which we are going to use as a coolant in the machining process. Heat absorption, lubrication, high flash point, stability, neutral, odorless, harmless, non-corrosive, as well as transparency, low viscosity, as well as low price. Next, how you are going to choose the cutting fluid? It depends upon different properties or factors. The first factors is being type of operation what we are doing. So this type of operation also depends upon the parameters what level we are taking. If the levels of the parameters are very high, that means depth of cut is very high, cutting speed is very high, the operational way is also different. So the type of operation, whether you are doing it on a lathe, that too facing or turning, so it depends upon the nature of operation. Point number 2 is that how much material you are going to remove, whether slight in terms of powder or slight in terms of discontinuous chips or segmented chips or continuous chips with a larger width. So it depends upon the rate of material removal rate. The choice of the fluid depends upon. Next is material of the workpiece. Material of the workpiece, in a sense, we do have only two natures in the workpiece, that is ductile and brittle. So what type of material we are going to use, depending upon the type of material, so the choosing of the cutting fluid should be carried out. Next is tool material. So there are different n number of tool materials also available depending upon the work material. So we know the relation that tool should be always harder than the workpiece. Similar concept, material of the tool will also affect the choice of the cutting fluid which we are going to select. Next is surface finish required. So in general, the machining process takes place to improve the surface finish or to get required dimensions. So the required dimensions, if it is important, the surface finish may not have importance. But if the possibility is that if you want surface finish as a character, if you want surface finish as a character of improvement, then we need to select a proper cutting fluid so that it should satisfy the requirement. Next, the last one is being cost of the cutting fluid. So cost of the cutting fluid, generally the cost of the cutting fluid increases. It depends upon the nature of the fluid. If it is viscosity very low, it is odorless, if it is harmless, then the choice of the cutting fluid generally will be very high. That means the cost pertaining to the buying of the fluid will improve. That means it will increase. Now we are going to see what are the different types of coolants available in the nature with respect to machining process. There are only 4 different types of coolants that are cutting fluids available in the nature when the machining process is taking place. So those are water, soluble oils, straight oils and mixed oils. So these are the 4 different types of coolants available in the nature when the cutting process is carried out. So first we will see water. So water is available free in nature, so which is very easily available as well as it is very cheap. So pure water by far is the first cutting fluid which were being used in the olden days. So there is a backdrop of this cutting fluid, that is nothing but it will make the workpiece corrode very fastly. Because the nature of the cutting process is that the cutting will go up to the high temperatures. Due to the high temperatures, the water generally at the high temperature, the material attracts oxidization. Due to that attraction of oxidization, what happens? The material after machining will corrode the work material, that work surface or work material. So generally, water is so far a best cutting fluid. Rather than, I can say that it is the most freely available in the nature as well as it is easily can be get into a point of machining. So first one is water. The second one is soluble oils. So soluble oils are different oils which are taken into a less percentage when compared to the water. So what happens here? We can take concentrated oil. So concentrated oil is taken. So this concentrated oil is diluted in water. So diluted in water means the dilution percentages are different. Suppose you want to have thick fluid, the dilute percentage of the concentrated oil is decreased. If you want to have high movement, that is low viscosity, so thereby you will add water heavily. So I mean to say, if you consider 10% of soluble oil, the rest of 90% will be the water. So it describes the operation. So whatever operation you are carrying out, it depends upon the operation, what are the types of work material, tool material, etc., etc. But the general amendment for going into machining process is that, so dilution of the water depends upon the operation, the other characteristics. Dilution means 10% of concentrated oil with respect to addition of water will make it into soluble oils. The definition of soluble oil stands like that: it is an additive to a water to improve the wetty characteristics. So the wetty characteristics is nothing but improving the cooling percentage, improving the cooling process. Now, additives are added to improve lubrication characteristics. You can add one additive or number of additives to the concentrated oil so that it can be converted into soluble oils. Next, the third one is straight oils. Straight oils are nothing but these are pure mineral oils. Generally, there are no additives in this process. So, no additives means no adding of water. In general, the coolant, if you want to prepare, so generally we have pure oils and mixed oils. So, pure oils only stands where you use only pure mineral oils. No other additives are required in this. So, they will not go under any additives. Straightforward, whatever extraction from any process that we will use as a lubrication. The main function of this is to prevent rust as well as to give stable lubrication. So these are the two main functional characteristics of straight oils. So in general, the straight oils are very, very important where you want to have good surface finish, where you want to have rust prevention. There we need to use straight oils. Next, it should be chemically stable. Generally, the straight oils are chemically stable, and in some areas or in some places where these straight oils are available in abundant are very less in cost. Next, you can use it for light duty application. Light duty means where the parameters that cutting speed, feed and depth of cut have minimal in condition. There we can use it. Next, these are nothing but extraction of fatty oils, mineral oils, petroleum fractions, etc. So, straight oils are the bifurcation of fatty oils, mineral oils, as well as petroleum fractions. So, in general, I can say that straight oils are pure oils where no additives are being identified for cutting process. The last one, we do have mixed oils. So, mixed oils are nothing but generally, these are two different types of oil. You have mineral oils, next, plus some additive mixture. So, mixed oils are created by pure mineral oils plus additive to the mineral oils. So, this is the largest variety of the cutting fluid available commercially. So, mixed oils are very have come into picture after the machining process has been changed, conventional to non-conventional. So, in process of developing the machining process into a different stage, the mixed oil has come up. So, here the mineral oils and additives will create the mixed oils. So, this is the largest variety of the cutting fluid available commercially. They will be where you have a situation which is very difficult to machine. There it is also very suitable where you will have a neat oil application. Next, the additives are fatty oils or EP extreme pressure oils. So EP stands for extreme pressure oils. So in general, where you have difficulty in machining, where the heat generation is very high in the process of machining, there we can use mixed oils. So, in summary, I can say that there are 4 different types of coolants what we are going to use. Those are water, soluble soil, straight oils and mixed oil. Water is pure water, no additives. It is freely available in nature. The second one is soluble oils. Soluble oils is mixture of soluble oils plus water. So, you need to add some additive in terms of percentage with water that makes it a soluble oil. Straight oils are straightly extracted from the fatty oils as well as mineral oils as well as petroleum fractions. Straight oils, there will not be any type of mixture. These are neat oils. Next one, the fourth one is mixed oils. Here you have extraction of straight oils plus the other additives like extreme pressure oils as well as fatty oils. So this is what the type of the coolants are available in the machining process. The second topic what I want to discuss, we have some examples related to it. So water, we have distilled water, boiled feed water, etc. Soluble oils, you have castrol, next mobile cut. These are some examples of different brands available. Straight oils or pure oils where the content of water is zero. So you have castrol, very cuts. Next mixed oils. So it varies. Oil plus water or synthetic blend you can do where you have shell tusses, biodegradable oils. So in general, this is the content, water content. So you can see here water in 100% in water. So 30 to 90% is the addition of water in the soluble oils. Now the straight oils, you have 0% of water because there is no additive in it. Then the mixed oil, maybe it is a soluble or straight oil. Both you can have blending nature. Fluids normally used in market are carbon tetrachloride, acetic acid, turpentine, kerosene, paraffin oil, soluble oils as well as water. These are some example of fluids which are being used to carry away the heat. Next, we will see what is machinability. So machinability is a thing which justifies the machining process. In general, I can say that if you want to define it, it is what with ease or very easily to do the machining process. So in general, the ease with which a given material is cut under given cutting condition with the help of the tool. So machinability is an index number. So the index number says that how easy you can machine the given material with the help of the tool, with the help of the different parameters. So it generally depends upon the chemical composition of the work material. So work material, generally we do have classification in two types. One is ductile type, the other one is brittle type. So the chemical composition present in the work nature will define how easy you can cut the material with the help of the tool under different parameters, levels. Those are cutting speed, feed and depth of cut. The next one is microstructure. So microstructure also very important because nowadays we are having different types of additives in the materials. Maybe it is metal matrix composites or metal matrices, etc. So the study of microstructure will help us to define the machinability of the given workpiece. Next is the mechanical properties. There are different mechanical properties, toughness, hardness. All these are defined to have a machinability index properly. Next, cutting conditions. Cutting conditions are nothing but how the cutting process is taking place, with what level of RPM, what level of depth of cut and what level of feed is applied, how much power has been given input. So what type of operation we are going to have. So all these factors will contribute to the machinability index. So generally it is defined as with how easily you can remove the material from the workpiece given with the help of the tool by using different cutting conditions, that means different levels of the parameters. So that is how the machinability is defined. So the effect of cutting speed, feed and depth of cut is represented with respect to the machinability. So machinability criteria generally depends upon tool life between grinds. So easy with which we need to take the material out means the tool should be very sharp. Next one, the value of the cutting forces. If the cutting forces value increases, thereby the machinability index decreases. Why? Because the cutting force directly involves in the machinability. The cutting forces are very high, the machining is not very easy. Next one, the quality of the surface finish. So if you want to have good quality of surface finish, machinability index should be improved. That means the number of machinability should have a larger in the area. Next one is the form and size of the chip. The form and size of the chip. Form means the area of the chip as well as the size of the chip. If the size of the chip is very larger, that means the machining index will decrease. If the size of the chip is very smaller, that means along the surface and it is very smoothly going, then the machinability number index number will increase. The temperature of the cutting, it should be in the control condition. The temperature of the cutting should be in the control condition. If it is not, then the machinability index will increase. Next, the rate of the cutting under standard forces. The lastly, material removal rate. So these are all criteria on which the machinability number or index depends upon. So generally, good machinability implies satisfactory results in machining. If the number of machinability is good, that implies that the result in machining is very, very high. So generally, machinability have a criteria that the removal of the material should take place very easily. If the removal of the material doesn't take place very easily, that means that the machinability number is decreased. Thereby, the satisfactory levels in the machining will come down. So generally, if you are assuming that the good machinability is going on, that means the machining is having a proper results. Next, it is not a basic standard, but it is very relative. So we can't say that machinability is the basic standard for saying that the machining is going very perfectly, but it is a relative method for saying that the machining surface is very good. The rated machinability of two or more metals being compared may vary from different process of cutting. So the machinability number, whatever we calculate, may differ from operation to operation and the process of cutting nature. So it is compared into a machinability index. So this is an index. Index is a number. So we can show it in terms of index. So let us see the index. The machinability index of free cutting is arbitrarily fixed at 100%. Generally, we say that we have to fix it into the 100%, that which is very free from cutting. So for materials, in general, how it is calculated means M is equal to cutting speed of the material for 20 minutes true life divided by cutting speed of the standard steel for 20 minutes to life into 20. So this indicates that the use of cutting speed for a material with respect to the tool life, which is of 20 minutes, has to sustain the standard relation of the cutting speed of the steel, which also sustains the tool life for 20 minutes into 20. So all are 20s. Okay, thereby if you have a value, so if you take the values, cutting speed for a material, cutting speed value for a standard into 20 will give you a number which says that 90. Okay, so 90 means the number is very high, 90% in terms of percentage. So the number is very high. So that means if the number is very high, that sense that the machining is taking place very easily, and the number indicates that the output of this machining is very good. That means the surface created by this machining operation is also very intact. So remember that the machinability index is a number which says that how easily the material can be removed from the workpiece with the help of the tool. So with the help of the tool, the number can be found out with respect to the cutting speed of the material what you are going to use with respect to the tool life for 20 minutes, as well as a standard steel has been considered with its cutting speed for tool life of 20 minutes into 20. So this defines the machinability index. So what are the objectives for economical machining? So objectives are depending upon the machinability is related to quick material removal rate, how fast the material can be removed from the process of machining. So in the process of machining, depending upon the parameters, so if the depth of cut is very high, the material removal rate will be very low. If you want to have economical machining, there should be a quick material removal rate process. Next, the second type of objective is low tool cost. The if you want to have economical machining, you need to maintain the tool cost very low. Next, good surface finish should be obtained. Next is minimum idle time of the machine. That means there should not be any space in the process of operation to operation. There should not be any idle time, so that the machine utilization should be 100%. Then only I can say it is economical machining. The last one is less power consumption. So if it depends upon the number of factors, even though if the consumption of the power is very low, then I can say that the machining is going on very economically. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.